Hello everybody. Today's topic of our notes is electricity. So get out your notebooks. We're going to record this in the input side of our notebooks, and let's get started. Here is our essential question for today. How is lightning similar to getting an electric shock when you reach for a metal doorknob? Have you ever experienced that before, walking across the floor with some rubber sole shoes on, and you touch the doorknob and it jolts you. It gives you a little bit of a shock. So by the time we get through our notes today or get through our foldable activity for today, you'll be able to answer this question. How is lightning similar to getting an electric shock when you reach for a metal doorknob? All right, so again, the title of these notes are electricity. So when you go to turn this in on eBackpack, you're going to look for electricity notes and lightning foldable. All right, our first vocabulary word for this section is electric charges. Electric charges are from protons, which are positive, and electrons, which are negative. Okay, so electricity and electric charges is all really about the structure of the atom. Remember, protons are found in the nucleus of an atom, and they're positively charged. Electrons are found outside the nucleus of an atom, and they are negatively charged. Static electricity is the accumulation or grouping up of excess electric charges on an object, which could be positive or negative. So static electricity, whenever you experience that, like whenever you're taking some clothes out of the dryer in the middle of winter, they stick together sometimes and you pull them apart and you see that static and you feel the little shocks. It's because as the clothes were in there, something became slightly positive and something became slightly negative, and when you pulled them apart, it conducted that electricity. Atoms become charged by gaining and losing electrons. Remember when we studied the section on ions and ionic compounds? The way that happens is if this atom were to lose some of its electrons, it would become positive. But if it would gain more electrons, it would become negative. Okay, a very important thing is the law of conservation of charge. As atoms become positive or negative, something else is becoming positive or negative as well. Electric charges can be transferred from object to object, but cannot be created or destroyed. So an atom doesn't become positive unless something else becomes negative, is another way to state that. And we all know this, positive and negative charges exert forces on each other. When you have a positive next to a negative, they're going to attract each other, so opposites attract. And if you have two positives or if you have two negatives, they're going to repel each other. So like charges do repel each other. And next here, we're taking a look at conductors versus insulators. Conductors are materials in which electrons flow easily, such as metals. So other things would be different types of metals, such as aluminum, copper, iron, gold, cobalt. Okay, those are all metals. They are really, really good conductors of electricity because those electrons can move really easy. Insulators are materials where the electrons are not able to move as easily as they are in conductors. Some examples of these are wood, plastic, rubber. Paper is not a very good conductor, so it's an insulator. And we see here, this is like a cross-section of a piece of wire that's been cut off. It's a drawing, it's a digital drawing, where we have copper on the inside as the wire. This is the good conductor, and our insulator here is rubber. All right, it can also be made out of plastic. Now, objects can become charged by a multitude of different ways. There are two ways here. The first one is charging by contact. Whenever something is being charged by contact, it's the process of transferring charge by touching or rubbing. So like I was talking on a winter day, when you drag your feet across some carpet, you are building up a charge in your body. And then whenever you go to touch a doorknob, it zaps you, okay? Because the electrons pass from something neutral to something different. And here's an example of this. If we have a sphere that is neutral and we move a positively charged rod next to it, what happens is some of those electrons are going to charge that rod. They are going to move from this sphere to the rod. Okay, so charging by contact is the process of transferring electrical charges by touching or rubbing. Now this other one over here is charging by induction. This is the rearrangement of electrons on a neutral object caused by nearby charged objects. So here we've got the sphere and we've got this positively charged rod near it. And notice what happens is that the charges that are inside the sphere rearrange. It becomes more negative where the positive influence is, and then the positive charges repel from that positive rod. Okay? Charging by induction is kind of a cool thing. We now have like charging stations for charging iPads and phones and stuff like that, where you don't even have to plug them in at all. You can just have them sitting next to something and it'll charge that machine, that battery. And that's all because of charging by induction. Okay, now pay really close attention to your instructions for your lightning bolt foldable. We're going to read a little section on how lightning forms, and then we're going to organize it in a really cool visual way. All right, thanks for paying attention. Remember to go back and answer that essential question.